How's it going, guys? So we're back! Wow. Sorry, I would have started earlier today, but my day's been quite hectic, quite busy, quite amazing, as all things should be. And I'm pretty excited, because up until now we've mainly just been doing our projects. Or the one project, the log formatter, which finally got completed, and then I kind of felt lost because I put like so much time and effort into it, and then when it was done I was like, what now? But thankfully we still have some studies to do, because I feel there's so much more that I still want to do, and some things I still struggle with, I'm not gonna lie. I've learned a lot from building the project, and I feel that's gonna help, especially with the studies. But I'm looking forward to seeing the new things that we can discover, and hopefully that will help us with new projects, because there's quite a few projects that I would like to build, and I can't wait for that. But let's see where we get. So we're back with object-oriented programming. We stopped just shy of the halfway mark, and we can take it from there. So we're going to be looking at inheritance today. Let me make sure I get this. Cool. So, inherit behaviors from a supertype. In the previous challenge, you created a supertype called animal that defined behaviors shared by all animals. Where function animal.prototype.eat equal to a new function console.log nom nom nom. This and the next challenge will cover how to reuse animals' methods inside bird and dog without defining them again. It uses a technique called inheritance. This challenge covers the first step. Make an instance of the supertype or parent. You already know one way to create an instance of animal using the new operator. There are some disadvantages when using this syntax for inheritance, which are too complex for the scope of this challenge. Instead, here's an alternative approach without those disadvantages. Let animal be object.createAnimal.prototype. Interesting. Object.create object creates a new object and sets object as a new object's prototype. Recall that the prototype is like the recipe for creating an object. By setting the prototype of animal to be animal's prototype, you're effectively giving the animal instance the same recipe as any other instance of animal. Animal.eat prints nom nom nom. Interesting. Animal instance of animal. True. And also, that's weird that we have it as lowercase versus uppercase, because obviously they're different. The two variables aren't the same due to the case sensitivity of JavaScript. It's weird that they'll do it as this example. They could have literally just said dog, like let dog equal new animal. I guess they were trying to show inheritance or whatever. So use object.create to make two instances of animal named duck and beagle. So you want me to create two instances of animal. So object.create, and they were animal, right? Animal.prototype. And we can literally just copy this for the next line as well. There we go. They have now inherited and figured a way how to eat. At least they won't die. from malnutrition at least. Set the child's prototype to an instance of the parent. In the previous challenge, you saw the first step for inheriting behavior from the supertype, or parent, animal. So we refer to the parent as the supertype. Interesting, okay, so supertype parent, got it. Though it's interchangeable, I guess? Because for CSS and JS, you refer to us as the parent and the child. This challenge covers the next step. Set the prototype of the subtype. Okay, so supertype and subtype, parent or child. In this case, bird, to be the instance of animal. Bird.prototype equal to object.create animal.prototype. Remember that the prototype is like the recipe for creating an object. In a way, the recipe for bird now includes all the key ingredients from animal. Let duck equal to new bird Donald. Duck.eat prints nom nom nom. Duck inherits all of animal's properties, including the eat method. Modify the code so that instance of dog inherit from animal. So we've got beagle.eat. So we're doing this in a different way now. When you call dog, so we should probably say object.create animal.prototype. We have animal. Oh, why are these empty? Animal.prototype. Got animal, eat. Remember that the prototype is like the recipe. Duck inherits all. Right, modify the code. Oh, hold on. Was I not supposed to touch these? Because I see animal is also empty and it says only add your code below this line. So was I literally just supposed to do what I did in the previous one? Object.create animal.prototype? Is that what they want? Beagle? What is beagle? Let beagle equal to new dog. But we haven't modified dog either. And dog should inherit from animal. Dog.prototype equal to object.create animal.prototype. There we go. That's what I was missing. Just trying to figure out, yeah, they confused me. I don't know who wrote this, but why would we have empty functions? I guess they were just trying to show us the inheritance of animal, so we don't have to add anything in animal. If we wanted eat, we just inherit it from animal. That must be it. So animal, that extends, I guess you could look at it in that way, or the prototype of it. Then dog's prototype is just going to be object.create inherit animal's prototype. So get everything of that in there. Onwards! Reset an inherited constructor property. When an object inherits its prototype from another object, it also inherits the supertype's constructor property. Here's an example. Function bird, bird.prototype equal to object.create animal.prototype. Let duck equal to new bird. Duck.constructor, function animal. But duck and all instances of bird should should show that they were constructed by bird and not animal. To do so, you can manually set bird's constructor property to the bird object. So bird.prototype.constructor equal to bird. Duck.constructor, it's bird. Right, and then we could probably use bird instead of animal. Fix the code so duck.constructor and beagle.constructor return their respective constructors. Right. So duck so bird.prototype.constructor equal to bird, and dog.prototype.constructor equal to dog. Add methods after inheritance. A constructor function that inherits its prototype object from a supertype constructor function can still have its own methods, in addition to inherited methods. For example, bird is a constructor that inherits its prototype from animal. Function animal.prototype.eat has function bird, right? Bird.prototype object.create animal.prototype. Bird.prototype.constructor is bird. In addition to what is inherited from animal, you want to add behavior that is unique to bird objects. Here, bird will get a fly function. Functions are added to bird's prototype the same way as any constructor function. So bird.prototype.fly is a new function, console.log I'm flying. And that's cool because you set the constructor to bird. So that means every time that you create a new bird object, it's first gonna build from animal and inherit animal stuff, and then we're gonna additionally add from bird, which is pretty cool. I like that. Now instances of bird will have both eat and fly methods. Let duck, new bird, duck.eat, print nom nom nom, duck.fly, I'm flying! Add all necessary code so the dog object inherits from animal and the dog's prototype constructor is set to dog. Then add a bark method to the dog object so that beagle can both eat and bark. The bark method should print woof to the console. Right. So we first want to set the prototype. So we're going to go dog.prototype equal to did we set dog's prototype? No, we haven't, so we should. Object.create animal.prototype. Then we should set the prototype constructor to dog. And then in the function, probably also add one here. Dog.prototype. What was it? Bark? Yeah, it was bark. Equal to function. And you want us to log woof, right? Just woof. Was it woof? Yeah, woof. So create animal.prototype, set the constructor to dog, and it will inherit all of the methods on the dog prototype, so that should automatically be added. So when we create the new dog, it should say woof. That should be it. Beagle.bark is not a... Do I have to add this after the declaration? Is it like same as hoisting? Oh, I do. Why? That's a bit weird. Dog.prototype.bark is a new function. Is it hoisting? I'm wondering, is that the reason why this doesn't work if I declare it before? Because here I'm saying create a new animal prototype, set its constructor to dog. Is it because of the constructor that comes afterwards? Or is it the animal create? I think it's that one. Yeah, that's the reason. Okay. So when you create a new object and inherits animal, that needs to come afterwards. Fair enough. Cool. Override inherited methods. In previous lessons you learned that an object can inherit its behavior, methods, from another object by cloning its prototype object. Child object.prototype equal to object.create parent object.prototype. Then the child object received its own methods by chaining them onto its prototype. Child object.prototype.method name equal to function. It's possible to override an inherited method. It's done the same way by adding a method to child object.prototype using the same method name as the one to override. Here's an example of bird overriding the eat method inherited from animal. Function animal, animal.prototype.eat, function bird, inherit all method from animal, bird.prototype is object.create, animal.prototype, cool, bird.eat, overrides animal.eat, bird.prototype.eat. So you call the same method and you override it. So because it finds two eats, the one declared last wins and it will return peck, peck, peck. If you have an instance, let duck equal to new bird, and you call duck.eat, this is how JavaScript looks for a method on duck's prototype chain. Duck greater than equal to greater than is eat defined here? Or no, are they just trying to say, is eat defined here? No. Bird, is eat defined here? Yes. Execute it and stop searching. Animal, eat is also defined, but JavaScript stops searching before reaching this level. Oh, so it goes up the chain. Instead of down, it goes up. So the actual object, the constructor of the object, the super type of the object, and then the object. Override the fly method for penguin so that it returns. Alas, this is a flightless bird. We have a penguin now! Oh, they bring the penguins back. Makes me so happy. Okay, so override the fly method for penguin so it returns. Alas, this is a flightless bird. Poor penguins, they don't get to fly. So penguin dot prototype dot, was it fly? Yeah, dot fly equal to function return. Alas, this is a flightless bird. Then again, you know, I mean, learn to fly taught me that penguins actually can fly. They just need a bit of help, you know, with some gliders and just, you know, a little bit of help. Penguins can definitely fly. They just need some help. Poor penguins. Okay, so that should be it. There we go. Use a mixin to add common behavior between unrelated objects. Interesting. A mixin. This is something that I learned through like CSS stuff. This is cool. As you have seen, behavior is shared through inheritance. However, there are cases when inheritance is not the best solution. Inheritance does not work well for unrelated objects, like bird and airplane, yeah, if you had a fly method. They can both fly, but a bird is not a type of airplane, and vice versa. I mean, if the bird was big enough, we could fly on it, couldn't we? Like back in the day, if we go to like the what was it, era where we had pterodactyls and all that, you could totally fly them. So they would be a type of airplane. For unrelated objects, it's better to use mixins. A mixin allows other objects to use a collection of functions. Interesting. Let fly mixin equal to function, and it takes an object. Object.fly function console.log flying whoosh. The fly mixin takes an object and gives it the fly method. Let bird, name Donald, with 2 legs, a bird with 2, oh of course, yeah. Let plane, model 777, fly mixin, bird, fly mixin, plane. Oh, that's cool. So you basically give them flying based on that. Here, bird and plane. This, I don't know why, like, all I could think of when I think of objects is just like games. Like, I want to make games. Like, think of all the cool stuff you could do. Like, an RPG where you can literally create a crazy amount of variation with, like, equipment and stuff. Just purely based on, like, using prototypes. Oh, we definitely have to look into that at some point. One of my projects for sure. Here, bird and plane are passed into a fly mixin, which then assigns a fly function to each object. Now bird and plane can both fly. Bird.plane prints flying whoosh, plane.fly prints flying whoosh. Now note how the mixin allows for the same fly method to be reused by unrelated objects, bird and plane. Create a mixin named glide mixin that defines a method named glide, then use the glide mixin to give both bird and boat the ability to glide. That's cool. So what are we gonna do? Let glide? Hold on, let's go here. Glide mixin equal to function, and we're gonna take an object. Object dot glide is a new function. Console. Are we gonna log anything? Did they say we need to log? Doesn't say anything. What type of sound does a glide make? Gliding. Is that a sound that you would make? If you What type of sound is a glide? It's almost like a whoosh as well. Oh, this is so random. Okay, what now? Then use the glide mixin to give both bird and boat the ability to glide. So bird dot oh right, sorry, we need to call our function. So glide mixin, and we're gonna give it, what was it? Bird and glide mixin boat. You know what I'm wondering? If we use the spread, was it rest? If we use the rest parameter, so we go like that. Was it like that? Then everything. I think it was like that, right? Because then you can go bird and boat all in one. Because it like supports basically an unlimited amount of parameters. That would be easier than having to write glide mixin every single time for every line. I don't know if it's going to allow us to pass the test though. I just want to double check. It was the rest. Just make sure I got that right. Supposed to be. Oh, because I'm not calling that. Would I have to use for each? Hey, how's it going, calculator? It's good to have you here. Haven't seen you around before. Someone new? Welcome. Yeah, it was the right one. I just gotta figure out how to use it now. That's fine, because that turns it into an array, if I'm not mistaken. So console.log object should be an array. Yeah, so it's like 2 items. So I'm probably gonna have to use for each then. Would probably be the best. Is there better? Because they use reduce, but I still don't understand reduce. I think you get it better the more you use it. And for each was so complicated before, but I've used it so many times since, so it makes it so much easier. But I think reduce is, I've always seen it in like mathematical uses. I could be wrong, but I know I could use for each. So for each item on the array, so you'll do something like object.forEach, then we would pass, I guess we could say, oh, we can't say object, let's give it a name. We already defined the object, and I can't use object because object is a reserved variable name. I can't think of something, so I'm just going to call it this object. And then we can do something like oh, we still need to add it as an actual inheritance now. I saw you on Twitter. Oh, that's nice. What's your Twitter handle? I don't think I've seen you around before. If I'm not following, I'll definitely drop you a follow. It's always good to be connected with the community. Are you also doing 100 Days of Code challenge? Tiago, right, yes, I am following you. I remember that. I saw something posted earlier. It's good to have you here, Tiago. Let's see, we need to define a glide method. Now, we're using for each, but we can't define the glide function inside of here because that just wouldn't make any sense. How do we convert this? But it would almost have to be like for each. Huh. I would have to add a .glide in somewhere. Almost like, because this has to be closed, if I'm not mistaken, so that needs to close like that. Then we do .glide there. Equal to function, would that make sense? No, that wouldn't. Yeah, I finished it once. I'm doing it again though. Nice, so it's like round 2. What are you going to do this time? Still documenting my way on. Okay. Nice, nice. But you're making progress, which is really good. It's always good to see that. Now I just gotta figure out how I'm gonna do this, because I have for each. That's gonna do something for every item in this array. But now I also at the same time need to declare a method. I've not done something like this before. And we can't do object like that or object because it's still an array. Actually no, I think I had it right. I think it is object for each. This object. Then we do this. Then we stick this inside of it. That actually does make sense. Reason being, you want to call it on each object and give it the glide method. So no, that is fine. That's good. Then close this up. There we go. So then what it's going to do is for every object in that array, we're going to add the glide method. Yeah, no, that is right, to this object. So then instead of having to call glide mix in each line, now that we accept basically what, an unlimited amount of parameters, we just call it with the colon. And there we go, that worked. Yes! I just want to challenge myself because they want you, well, they don't want you to, but this is how, you know, they did it in their example. So I'd have to call bird and boat with each line like that. And just imagine if you had a lot of them, bird, boat, this, that, you'd probably have like 20 lines of declaration. Whereas if you use the res parameter, you can have a single one and just separate them by a comma. So you have like the single line of declarations, one line versus however many. I'm just trying to like get better at writing more robust code. And I'm really proud of this one. So yay! That worked! So this is what they wanted, which should pass fine. And this is our improvement. Nice! Nailed it. Use closure. Yes! So this is what they were talking about because I didn't get this. I was working with it. So closures are basically when you have functions and functions. And I'm not used to that because one of the previous languages I worked on, that's invalid. You can't have a function in a function. So apparently this is called closures. And we're going to learn about it. Use closure to protect properties within an object from being modified externally. So what if you had like a local client-side game, maybe, and you don't want them to change the variable values? In the previous challenge, bird had a public property name. It is considered public because it can be accessed and changed outside of bird's definition. Bird.name equal to Duffy. Now here's the funny thing that I'm trying to think of, right? They say it protects it from being modified externally, but if you can just write a piece of code that can change that, how does it protect it? Does it mean that the only time you could change it is in the function itself, so you'd have to have access to the source code that is serving the page? So you, no matter what code you wrote, client side, you wouldn't be able to change the value, unless you change the source code itself, obviously. And calculator, it's a function that can access a value from an outer function. Okay, so therefore any part of your code can easily change the name of bird to any value. Think about things like passwords and bank accounts being easily changeable. Okay, well you'd never have that client side, would you? That could cause a lot of issues. The simplest way to make properties private is by creating a variable within the constructor function. This changes, yeah, we've worked on that before. Same as let. You can use, same as for loops. When you define like your I or your iterator or whatever inside of that, it's not accessible outside of that. We did cover that. That's cool. This changes the scope of that variable to be within the constructor function versus available globally. This way the property can only be accessed and changed by methods, also within the constructor function. So function bird, let hatched egg is 10. Okay, yeah, so you can't access hatched egg. This.getHatchedEggCount, this will give you the count of that, is a function, publicly available method that a bird object can use, return hatched egg. Let ducky equal to new bird, ducky.getHatchedEggCount will give you 10, whereas if you went ducky.hatchedEgg, you would get an error because hatched egg is not available in that scope. What did you work on before? What do you mean? Like the project that I was working on, or like studies-wise? Here, programming. I did a bit of modding for Skyrim, so that's where I like got into like the programming mindset. It's a very basic language, but it helped me, you know, get that whole critical thinking needed to solve problems, and that helped me, I guess, get into JavaScript. And what I like about programming is once you know how to do something or like what options you have, you can take that into any language. All it takes is you learning the syntax, really. Once you know what's possible, it's just like you make it happen. You find a way to make it happen. That's what I love. But as for projects, the only thing that I've really done is my log formatter. Is it available here? That's my local version. Let's go to my GitHub. Dead mono. github.io/100 days of code log formatter, I think it was. Was it this? Yeah, it was this. Yeah, so that's what I've that's the project that I've made in JavaScript. Which one you use for Skyrim? Papyrus is that what you mean? What language? So the internal scripting language, Papyrus. It's hard to say what it's like. People have said that it's similar to a bit of C and Pascal in some cases. It's very interesting. I got really confused when I came to JavaScript because you start the block scopes, not block scopes, block statements. So you have an if and an end if instead of, you know, parentheses, and that like confused me so much when I came back to JavaScript. So I had to like unlearn that basically. Yeah, it's niche. They made it literally just for their game engine. It works. It's amazing that they did that, but the more modern versions use C#, which is cool. So if I ever get into that, then I can make mods using C#. Yeah, it's like Lua. Yeah, I guess. Yes. Okay, so that's cool. So this is almost like get and set in a way. They could have covered closures in the get and set section actually. Because this is what you're really doing. You're returning something. It's not a get, obviously, but it's pretty similar. For a get, you would just say get this.getHatchedCount. It wouldn't be a function. So you would just call bird.getHatchedEggCount instead of having to add the parentheses. Just a nicer way to call it, I guess. Okay, so what do you want us to do? Change how weight is declared in the bird function so that it is a private variable. Then create a method getWeight that returns the value of weight. Right. So this dot weight, instead it's going to be private. So let weight equal to 15. Is that what they want? And then we have to do this dot get weight is a new function, and we're gonna say we're just gonna return weight, I guess. That's all. Is that what they want us to do? Create a method getWeight that returns the value of weight. Yeah, that should be it. Do I have to like write anything else? Do I have to call it? Should create a method in bird. Do I have to like test it? Or is that it? Just like that. You don't even... How are we even calling the function? You would think it's like let big bird equal to new bird or something. That's weird. Okay, so very inconsistent. They just want us to write a function that works. It works. The one thing I don't like in JavaScript is the prototype you say calculator. I came from OOP languages and it's so weird even now. But isn't JavaScript based on OOP? I mean that in Java? Do you mean, are you referring to specifically the constructors? Because I heard a lot of people refer to that. Like ES6 makes that better with classes and stuff. Because prior to that, no classes I would understand. Like especially the C languages. You don't have like any classes. And you would have to basically have fake classes like pseudo classes. But now you at least have classes in ES6. So that's really nice. So you could just do like dog class equal to, you know, whatever, and you have like constructor and have the constructor for it. So that's really nice. What do they want us to do here? It's just syntactic sugar, yeah, I know. But you can use it at least, and it works. It's not quite the same, but at least it emulates that. Which is better. Like, I don't even want to know what this is. Prototype or something, like where you have that underscores. Like, God, that just looks awful. I hope I never have to use that. I really hope so. We still haven't covered it. We've done prototype, but not this. I think that's how you'd like do a class or something. A common pattern in JavaScript is to execute a function as soon as it is declared. Understand the immediately invoked function expression. Immediately invoked function expression. This is an anonymous function expression that executes right away, right? Because so you call it immediately. Note that the function has no name and it is not stored in a variable. The two parentheses at the end of the function expression cause it to be immediately executed or invoked. Can you put something in those parentheses and use it like, oh yeah, because you can't call it, that would be a bit silly, wouldn't it? This pattern is known as an immediately invoked function expression, or IIFE. Rewrite the function makeNest and remove its call so instead it's an anonymous immediately invoked function expression. Right, so we just do function and just take that and stick that there and remove all of that and remove that and you're good to go. Hold on. Am I... Oh, right. Those, you need those. You wrap that up. Why do we wrap it up? That's just a thing, like an argument needs to happen, and then you call that immediately. And that's it. Use an IIFE to create a module. What? An immediately invoked function expression, IIFE, is often used to group related functionality into a single object or module. For example, an earlier challenge defined two mixins. Function glide, function fly mixin, right. We could group these mixins into a module as follows. Let motion module function return. So we're using an anonymous function here, right over there. So function return glide.mixin function object.glide and fly mixin, right? The two parentheses cause the function to be immediately invoked. But if you invoke it immediately, you're not calling it. So where are you passing what object to get fly or glide? How does that work? Now that you have an immediately invoked function expression, IIFE, that returns an object motion module. Oh, because motion module, that's what you're calling. So you call motion module dot, and then you call glide mixin. That's so cool. So it's like an object inside of it. I'm just confused with the names that they give it now, like module. Is that an actual name? Because that, usually when you would call something dot something, it's an object, right? So that's a property on the object, glide? Because that's what it really is, it's an object. The key value pair. Interesting. The advantage of the module pattern is that all of the motion behaviors can be packed into a single object that could then be used by other parts of your code. Here's an example using, okay, yeah, it makes sense, it's neater and easier to use. So then you call duck.glide or duck.this or duck.that, duck.eat. Or rather motion, yeah. So you call motion module dot glide mixin duck. What was the purpose of creating the mixin then? I'm a bit confused, because glide mixin, why can't we just call object.glide is a function? It seems like an extra step. I think it's module because IIFE are a go-do way to make libraries or modules, reusable pieces of code. Okay. That reminds me almost like in one of my... I gotta remove this. I had a section somewhere here in one of my functions. Check max value and check min value. So instead of having these actual functions, because these are closures, I could have probably like done a module somehow. probably call it like check values, and then have check min value and check max value in it. I want to like test that in mine now. I'm just confused by the part here when it gets evoked immediately. What does it run? Like, does that just mean it's gonna fill the motion module? Or like, what are you running when you run that immediately? If you isolate all your code in an IIF, yeah, but what will happen? What will it call, like in this case? Because you need to pass something to it. You see motion module, later on they say motion module.glide mixin duck. That's calling that function. But what happens when you invoke it here? Like, what is it invoking? What is it doing? That's a confusing part for me. Do I need to have the parentheses there? Like, I don't need to evoke it, right? So then you return. Well, why do you return? What does the return? That's confusing. And this is for the second part. You gotta go? Cool, no worries. Thanks for dropping by, Calculator. I really appreciate it. I'm gonna try this module in my existing code and see how it works, and then yeah, I would have implemented something new, which is exciting. Function, and we take element class. And then this is what we stick in it. That's so cool. And the next one is check max value. There's also a function which takes element class and element max value. We mustn't close our return. Check max value, and then this is going to be max values code. Cool, and then after the return they close it off, and then finally Have this there.
Search for dollars insert.
Now let's figure out what we've got here. So we've got the opening and the closing.
Is that scary?
Close that. Then the return. So let's make sure we got open and close there. Perfect. Open and close there. Perfect. Perfect for the if. Do we have the if? Yeah, we do. That's perfect as well. So our two functions, open and close. Then we've got our return. And then we need to close the entire function, which is with that. Oh, we need another one? And then the function, that's empty. Why do I have that there? Oh, that's the issue. And then at the end of it all, close it like that. Unexpected unnamed function. Okay, it works, but otherwise it's an unexpected unnamed function. And then how would we use it? We would just call, based on their example, it would be so you would have to call check value dot and then the property you're wanting. So dot max value, for example, or check min value, and then you would have to pass in the element, and that's how you'd use it. And then let's just check the documentation why this is incorrect. Require or disallow named function expressions. Adding the second bar in the above function is optional. If you leave off the function name, then when the function throws an exception, you're likely to get something similar to an anonymous function in the stack trace. Oh. Examples of incorrect code. Food over equal to function. So give it a name. So instead of assigning it into a variable, can't we just do function check value? Can we do that? And then let's see if that works. Here's the old declarations. Check value dot check min value, give it element class, and then check value dot check max value. We need to give it element class and the max. And then we don't use these functions at all. We don't get any errors. Is this easy to maintain though? I mean, you have two functions which are side by side and they're easy to like work on, I would think, versus a single function or module as they refer to it. How is that easier to work on? Is it because you just call check value dot? It's a different way of doing it, I guess. See if it works. So it's supposed to give me an error here, which it doesn't do. Type error, check value.checkman value is not a function. Check value.checkman value, we pass it element class check value. When you call check value, it is a function. Is it because of the way I wrote it now? Probably is. So to fix this, it would have to be let check value equal to function, like that. And then you need to have that at the end, and then you need to evoke it immediately. See if that works now. Oh, that works. Okay. And check minimum value, yeah, that works. So now that we did that, the only issue is unexpected unnamed function. That's the one thing. Can we give it a name though? Just call it check, function check. Oh, it works. So you can give it a name if you needed to, just to avoid the ESLint erroring due to the Airbnb format. What is the benefit of us doing it this way though? Like, all we then do is call check value dot check min value, whereas before you can just go check min value this or check max value that. Now you're adding check value dot that. How is that like beneficial? I'm just trying to figure out why you would do it this way. I guess if it involves other things inside of it, which we're not doing, it's always only for one thing. Well, at least we converted it to that. I'm not going to use it because in this case it doesn't make any sense for us whatsoever to do. At all. I'm going to remove that. Go. Cool. So that was interesting. And what have we got here? So note that you have an immediately evoked function. Yeah, the advantage of the module pattern is that all of the motion behaviors can be packaged into a single object that can then be used by other parts of your code. Here's an example using it. Motion module.glide mixin.duck. Oh, I guess if you have a lot of things like combat, almost like document, that's how they do it. So like document.getElement by value, document dot, this document dot that. So if we think of our game mechanic again, so like magic, for example, so like magic dot fireball, magic dot this, magic dot that. So then you'll know it's always under magic. And it's in one, but yeah, I guess that would make sense. Not in our case, but in that case, sure. So create a module named fun module. And they're not even telling us where to put it this time. Add your code above this line. Oh, there's a cute mixing, a sing mixin. Aww, isn't that fun? So let fun module equal to function return, and then inside of it we need to have is cute mixin. So is cute mixin oh, hold on, so I'm gonna take literally all of this. So that's for that. That's for that. What's that for? That's for the return. So before the return, we need to have another one, which is going to be sing mixin. Which is going to be a function. So that's the return. So then we don't need any of these. It should just be a fun module. So function return is cute mixin. That's the first one. So that should be it. Do we have to call it? Or doesn't say anything about calling it, so let's check if we're good. Jeez, on the first try even. Yo, that makes me happy. That's so cool. We did it, guys! We completed the oops section! No ways! Oh, that is amazing! And those mix-ins were... yeah, mix-ins seem to be the craze now, eh? Even for CSS kind of stuff. Everyone's just like mixing stuff together. This makes it easier. Okay, so after that, after we completed that, so yeah, that's all complete. Then we got functional programming. Phew! I think I'm going to leave that for tomorrow then. Because we've done our hour for today. And it is the weekend. I want to try to get as much rest as I can in. I've just like completely burned myself out last week. But yeah, then I could just like tackle this on a clean slate. Start the Monday off hopefully a bit earlier than today. And then we're going to learn about functional programming, and thereafter we're going to do some intermediate stuff, which is going to be exciting. Finally, we're going to be like ready for some challenges, and then we're going to do some projects. Yo, I can't wait. It's going to be fun. 5 projects. Ah, it's going to be so awesome. Yeah, so tomorrow, functional programming. Exciting stuff. I can't wait. Hope you guys enjoyed the little short stream though, and I hope you guys are having a awesome weekend, having fun and enjoying yourselves and relaxing before the crazy busy week ahead. So yeah, I'll be back tomorrow. We're going to tackle functional programming. So until then, bye for now.